calculus. We all know that calculus plays an important part in the 12th grade portions, and it comes approximately from 40 to 44 marks. So already we have done 50% of the part by finishing off the differentiation, and another 50% we are going to learn under this topic. The topic is integration. Across the boards it covers around 18 to 22 marks. Topics for today: Introduction to Indefinite Integral, Basic Formula of Integration, Geometrical Interpretation of Indefinite Integrals, Difference between Differentiation and Integration, Substitution Method followed by examples. So let us get started with the topic. Indefinite integrals we are going to understand in today's video. Integration is nothing but finding the primitive of a function. So let us have a look on some questions. For example, I have fx is equal to x cube plus 3. F dash x is 3x square, right? So from here, if I want to go back, that is nothing but the process of integration. From f dash x, if I want to get back my fx, that is nothing but the getting back the primitive of a derivative. So the process of getting back the primitive of the derivative is nothing but integration. Now let us take some examples. If I find the derivative of this function, I'll get 3x square. If I find the derivative of this function, I'll get 3x square. If I find the derivative of this function, I'll get 3x square, right? Though my functions were different, but the derivative is same. So in that case, when I am talking about the primitive of 3x square, how I am going to write? I will write the primitive as x cube plus c, where c will denote any number, right? It can be the function fx is equal to x cube minus 8 or fx is equal to x cube plus 23 by 2. So c can be any value belonging to real number. Is it clear? So that is nothing but what is the meaning of integration. For f dash x equals to 3x square, I have fx is equal to x cube plus c. So what does this represent? It represents the family of curves. So basically I can say integration represents the family of curves. Okay. How integration is denoted? It is denoted, this is the symbol of integration, symbol, right? This is known as integrand. This is the element of x, okay? And from here we come to know with respect to what we have to integrate, right? In this case we have to integrate with respect to x. Had it been be like this, we have to integrate with respect to theta. Had it been be like this, we have to integrate with respect to t. Differential of sin x is cos x, right? So what I can write as integration of cos x is sin x plus c. Please don't forget to write plus c, because every integrand tells about the family of curves, right? So this plus c is nothing but integration constant, and it represents the family of this curve. So now let us have a look on other different formulas of differentiation from which we can obtain the integration formulas. Okay. Let us have a look on some standard results of integration. d upon dx of integration of fx dx is nothing but equal to fx. So what does this imply? This implies that differentiation and integration are inverse of each other. Now see the second property. Say for example you have integration k fx dx. So if it is a constant, you can take it out and fx dx. You have to integrate 2x dx, right? So you can take out 2 outside and you can integrate only x dx. Now third is, if you have fx plus minus gx dx, right? How you can write? You can separate them, right? Okay, this result can be extended to more integrands also. Say for example, plus minus hx, plus minus wx, plus minus px, plus minus qx. So you can separately integrate them. So just now we studied some formulas. Let us have look on some basic questions. So I have a question, x4 dx. Just now we studied x to the power n dx is equal to xn plus 1 upon n plus 1 plus c. So what this will become? X 4 plus 1 upon 4 plus 1 plus c. Say for example you have, okay, so what it will become? Sin x dx minus cos x dx. So integration of sin x is, and this integration is sin x plus c. Okay, now let us learn what do you mean by the geometrical interpretation of indefinite integral. So to understand the geometrical interpretation, what I'm taking my function fx is equal to minus 2x, and if I find the integration of minus 2x dx, I'll get minus x square plus c, correct? What does this represent? It represents the family of downward parabolas, right? We have parabolas of this kind, minus x square plus 1, whatever value I give to c, or y equals to minus x square plus 2, y equals to minus x square plus 3, and so on. Okay, this is y square is equal to minus x square, correct? I have given c as 0. It can be this, it can be this, it can be this. So these represent the parabolas, right? So this is my line, x is equal to a, p1, p2, p3, p4, right? What does indefinite integral represent? It represents the family of parabola. Also, I have drawn the tangents, right? And this line x is equal to a, it intersects the tangents at p1, p2, p3, p4, right? So if I find the slope of the tangent, it is minus 2a for each of the parabola. It means these tangents are parallel to each other, right? So what does it mean? It means geometrically indefinite integral represents the family of the curves also with the tangent parallel to the line which is orthogonal to the axis, which represents the variable of integration. What does that mean? So this is the axis which is representing the variable of integration, right? So let us now have a look on what is the comparison between integration and differentiation. The operations of differentiation and integration are defined on functions. The derivative of a function when it exists is a unique function, whereas the integral of a function is not unique. In fact, there are infinitely many integrals of a function such that any two integrals differ by a constant. The derivative of a function at a point is meaningful, but the integral of a function at a point does not have any sense. Every function is not differentiable. Similarly, every function is not integrable. The derivative of a function at a point determines the slope of a tangent to the corresponding curve at that point. The integral of a function represents a family of curves having parallel tangents at the point of intersection of the curves of the family with the lines orthogonal to the axis representing the variable of integration. The process of differentiation and integration are inverse of each other. The operation of differentiation and integration are operations on functions. Both the operations are linear. Differentiation and integration both are processes involving the limits. Broadly, integration is categorized among three. One is integration by substitution, integration by parts, and integration of rational expression using partial fractions. So let us first start with integration by substitution. So now let us discuss integration by substitution. Okay, so what type of integrals will come in this section? Integration f ax plus b dx, integration 1 upon ax plus b dx, or it can be ax plus b to the power n dx, or it can be sin ax plus b dx or cos ax plus b dx. This is first kind of integration by substitution. There are many kinds of substitution, right? We'll discuss slowly. Let us check one example of each. So let us take the example for this question. We have 1 upon 3x plus 5 dx, right? So let us assume this as t. We already know if we have a linear function, say for example if I have 1 upon x, I know it is log x, right? But instead of x, I have this quantity. So we'll try to change 3x plus 5 in terms of some other variable t, right? So let us take 3x plus 5 as t. Differentiated 3 dx is equal to dt. dx is equal to 1 by 3 dt. Now let us substitute. So in place of 3x plus 5, I'll substitute t. So 1 upon t. And what is the value of dx coming here? 1 upon 3 dt, right? I can take out 1 by 3 outside, and I know what is the integration of 1 upon t, that is log t, right? So it will be 1 upon 3 log t plus c. Now substitute the value of t. So we'll get 1 upon 3 log 3x plus 5 plus c. Is that clear? So this is the way of substituting and solving the integral of this kind, right? So guys, if we have an integrand of this kind, you can directly also write. Say for example, I have 1 upon 5 minus 7x dx, right? What I am exactly getting? I am getting log of this function, and whatever is the coefficient of x has been divided over here, right? So I am going to write directly here the answer. So it will become log 5 minus 7x upon, and what is the coefficient of x? Minus 7 plus c. Is it clear? So now let us take this part, 1 upon 8x plus 9 dx, right? So it will also become log 8x plus 9 upon 8 plus c, right? So whatever is the coefficient of x, with that you have to divide. And if it is 1 upon something, you have to take the log. Always you have to take log. And moreover, the power of x should be 1. It should not be square over here. Then your value of integral will change. Okay. Now let us take the example for this one. So say for example, I have 11x plus 8 to the power n dx. Now if this power n is square or cube, you can open it and you separately integrate them, right? But if it is something like 20 or 30, it's very tedious job to open and then do it. So how we are going to do? Simply by using substitute. So I'll take 11x plus 8 as t, right? And it will become 11 dx is equal to dt. Value of dx is dt by 11, right? Now substitute here. So integration, this will become t to the power n, and dx will be replaced by dt upon 11. 11 can come outside, right? Now direct formula will apply. 1 upon 11 t n plus 1 upon n plus 1 plus c. Substitute the value of t. So what is the value of t over here? 11x plus 8 to the power n plus 1 upon n plus 1 plus c. Try to relate. So whatever is the coefficient of x will come as 1 upon. Whatever is the power, it will be replaced by n plus 1 divided by that power. So say for example, if you have a question 7 minus 5x to the power 31, you have to integrate this part. So what you will do? First of all, what is the coefficient of x? Minus 5, right? So we'll write here, it will be equal to 1 upon minus 5, correct? Now we will increase one power. Okay, so it will become 7 minus 5x to the power 32 upon 32 plus c. This is your integral. Is it clear? So what you have to do, if you have an integrand of this kind, what you will do? You will increase the power, divide by that power into 1 upon coefficient of x. Okay. So everywhere, whatever is the coefficient of x, we are dividing with that. And our traditional formulas, whatever we have been using till now. So let us take now this example. We will check now these kind. So it is given integration 2x plus 3 dx. So let 2x plus 3 is equal to t. 2 dx is equal to dt. dx is equal to 1 by 2 dt. Let us substitute here. So sin t dt upon 2. We can take out 1 by 2 outside. So we are left with sin t dt. What is the integral of sin t? Minus cos t. So 1 by 2 minus cos t plus c. Now I will replace t by the actual value. So what we are getting? 1 by 2 minus cos 2x plus 3 plus c. Is that clear? So exactly what we have done, we have integrated sine. It became minus cos 2x plus 3 and we have divided with the coefficient of x. That's it. So this is the basic part of substitution. Now we'll move to the next category of substitution. Okay. Now let us take the integration of substitution by px upon ax plus b to the power n. Say for example, we have been provided by this type of function. So we will first check whether the degree of px is less than n or px is greater or equal to n, right? What does that mean? Say for example, you have here x square upon x plus 1 whole square. So here degree is same, right? Look here, px has the same degree like our denominator. Is it clear? Or if you have x upon x plus 1 whole square. So there are different ways of solving it. So whenever you have a degree equal to or greater than the denominator, so in that case first we divide and then we integrate. Okay. Had it been the lower degree, so what we do? We try to convert our numerator in terms of this. So look here how we are going to solve these two kind of question. So first of all, this question. Okay. What I will do in this question, I'll take x plus 1 as t, right? So dx is equal to dt. Now I have to find the value of x for the numerator. So what will be the value for the numerator? It will become integration t minus 1 upon t square dt. Is this step clear? Look here, this will become t, so t square, and x, from here I can find out the value of x. It is coming t minus 1. Now we will separate it. So what? T upon t square minus 1 upon t square dt. So it will become 1 upon t minus 1 upon t square, right? Now I can directly solve this. This will become log t, and this, in this I can use x to the power n plus 1 upon n plus formula, right? So separate it, 1 upon t dt minus, this will become t to the power minus 2 dt. So log t minus t minus 2 plus 1 upon minus 2 plus 1 plus c, log t minus t minus 1 upon minus 1 plus c, log t plus 1 upon t plus c. Let us substitute the value of t. So what is the value of t? X plus 1. So log x plus 1 plus 1 upon x plus 1 plus c. Is it clear? So now we will talk about when the polynomial in the numerator is greater than or equal to this power, right? So look here, say for example, I have a question x square upon x plus 1 whole square. So students, first of all, what we are going to do, we will divide, okay? So you can open the bracket over here. So look, okay? Now we will substitute over here. So always what we write? Question plus remainder by divisor. This is my question, this is my remainder, and this is my divisor, okay? So question plus remainder by divisor. So what is q? Q is 1 plus remainder is minus 2x minus 1 upon x square plus 2x plus 1 dx, right? Now I can separately integrate this part and this part, right? So I can write this as dx plus minus 2x plus 1. You can take out minus sign common upon x plus 1 whole square dx. Now this can be directly written as x, and how we will integrate this part, this we will check. So now this became the first case, right? So x minus this I have taken out outside, 2x plus 1 upon x plus 1 whole square dx. Let x plus 1 is equal to t, dx is equal to dt. Now substitute the values. So what is the value of x here? T minus 1 plus 1 upon t square dt. 2t upon t square minus 1 upon t square dt. Correct? This is minus 2 plus 1, it will become minus 1. So x minus 2 upon t minus 1 upon t square. Same thing, x minus 2 log t plus t minus 1 upon minus 1 plus c. Now we can substitute the value of t, x minus 2 log x plus 1 minus 1 upon x plus 1 plus c. So this is the required integration of this functions. Now let us check next type of substitution method. Let us check the integration of type now, or if we have an integration of this kind. So what we do, whenever we have such kind of integrand, always take the under root part as t square. So x plus 3 equals to t square. Dx is equal to 2t dt. Now we'll substitute. Find the value of x. What it will become? T square minus 3. Substitute here. Okay. What will be the value of this part? It will be, because it is in under root and I have taken x plus 3 as t square, so it will come as t. What is the value of dx? 2t dt. Students generally make a mistake in this part only. Please be very careful. Do sequentially the things. Substitute the value of x, then under root part and then dx. So you will not miss out any of the t. Bring the constant part outside and multiply t square inside. So t4 minus 3t square dt, right? Now simple integration. It will become t5 upon 5 minus 3t cube upon 3 plus c. Now we will substitute the value. Please pay attention here. So we have x plus 3 is equal to t square. So what does that imply? T is equal to x plus 3 to the power 1 by 2. So wherever I have t, I will substitute x plus 3 to the power 1 by 2. So what it will become? It will become 2 x plus 3 to the power 1 by 2, and outside you have 5 upon 5 minus, you can cancel out this 3, x plus 3 to the power 1 by 2, and you have 3 outside plus c. Now you can take 5 inside, so refined answer will become as x plus 3 to the power 5 by 2 upon 5 minus x plus 3 to the power 3 by 2 plus c. Is it clear? So whenever you have under root along with it, what you will take? Under root part is t square. Similarly, in this case also we'll take it as t square and solve it. Now let us take this question. It is of this kind. So again, I told you whenever under root part is given and both are linear, take this as t square. And it will become 7 dx is equal to 2t dt. T square differential is 2t, right? So dx is equal to 2t upon 7. Now from here I'll find out the value of x. So what it will become? It will be t square minus 9 upon 7. Is that clear? We'll substitute the values over here. So 3. What is the value of x over here? T square minus 9 upon 7 plus 5. So this will become t. And this will become 2t upon 7 dt. We can cancel this. Take out 2 by 7 outside and I am left with 3t square minus 27 upon 7 plus 5 dt. Right? Let us solve this part. So what it will become? 2 by 7 will come outside. 3t square minus 27 plus 35 upon 7 dt. Bring this 7 also outside, so 2 upon 49 will come out and you are left with 3t square plus 8. Now we can integrate. So it will become 3t3 upon 3 plus 8t plus c. Substitute the value. So what will be the value here of t? It is 7x plus 9 to the power half. So it will become 7x plus 9 to the power 3 by 2 plus 8, 7x plus 9 to the power half plus c. So now let us check the integration of this kind. Sine raised to the power m dx plus cos raised to the power m x dx. Sine ax cos bx dx, or cos ax cos bx dx, or sine ax sine bx dx, right? So if these kind of integrals are given to you, so what you are going to use? We are going to use the formulas of trigonometry, right? And these we are talking when m is less than or equal to 4. So look here, say for example you have integration sine square x. We cannot directly integrate sine square x. In that case, what we are going to do, we will change sine square x in terms of cos 2x formula. Very important concepts, and many places it will be used. So bear in this mind, if you have sine square x, sine cube x, cos square x, cos cube x, sine raised to the power 4x, we cannot directly integrate. What we have to do, we have to convert into cos 2x formula. So what we are going to write, so sine square x will be replaced by 1 minus cos 2x by 2. Had it been be cos square x, it will be replaced by 1 plus cos 2x. Sine cube x will be replaced by 3 sine x minus sine 3x upon 4. Cos cube x will be replaced by 3 cos x plus cos 3x by 4. So now let us take the integration of this part. So it will become 1 minus cos 2x by 2 dx. Take out 1 by 2 outside. So 1 minus cos 2x dx. And now you can simply write. So integration of 1 is x. Cos 2x will be sin 2x by 2 plus c. Is that clear? So whenever you have this kind of integrands, you have to replace them by these formulas, right? Now let us check one of this kind. So say for example, I have sin 3x cos 2x dx and I have to integrate this part. So what I am going to use, I will use the formula of sin A cos B. Okay. So we have already learned sin A cos B formula. What is the formula? It is 1 by 2 sin A plus B plus sin A minus B. Is that clear? So let us substitute that formula. So what we are getting? 1 by 2 sin 3x plus 2x plus sin 3x minus 2x. Okay. So 1 by 2 sin 5x plus sin x dx. Now simply we can integrate. So what it will become? It will become minus cos 5x upon 5. Whatever is the coefficient of x? Minus cos x. Here the coefficient of x is 1, so no need to write, plus c. This is the answer, right? Had it been b, cos a, cos b. So what you could have written? Half cos a plus b plus cos a minus b, right? Had it been b, sin a, sin b. What you would have written? Half cos a minus b minus cos a plus b. Is that clear? So if we use these formulas, we can directly get our answers to these type of integrands. Is that clear? So students, till now you have seen integration of cos x, integration of sin x dx, integration of secant square x dx, integration of cosecant square x dx, right? Now you might be wondering, what is the integration of 10x or integration of cot x, integration of secant x or integration of cosecant x dx, right? Now using substitution method, we will find the formulas for this and it can be used as a standard result. Okay. So let us take for 10x, write in sin cos form. Let us assume cos x as t minus sin x dx is equal to dt. Sin x dx is equal to minus dt. So what it will become? It will become minus sin x dx will be replaced by minus dt. So minus I have already taken out dt and this will become t, which is nothing but equal to minus log t plus c. I can write this as minus log cos x plus c, or from here I can write this part as log 1 upon t plus c, right? So it will become log 1 upon cos x plus c, or it can be log secant x plus c. Is that clear? Similarly, I can do the formula for cot x. So what will be the formula for cot x in that case? Log sin x plus c. Okay. Now let us check for secant x, and similarly we can write for cosecant x. Okay. So let us have a look for integration of secant x dx, right? What we will do, we'll multiply by secant x plus tan x. Now in the numerator I'll get secant square x plus secant x tan x upon secant x plus tan x. Assume this as t. In the numerator I have a differential of it. Secant x plus tan x equals to t. So what is the differential of secant x? Secant x tan x plus what is the differential of tan x? Secant square x dx equals to dt. This can be replaced by dt and denominator will have t. Integration of dt by t is log t plus c. Substitute the value of t. Similarly, we can do for cosec x. So viewers, now we are going to solve these type of integrands. This we have already used now to get the formula for integration of tan x, cot x and all, right. We'll do 1 or 2 more questions on that and then we'll move to this type of category. Okay. So let us take this question now. I know the differential of log x is 1 by x, right? So I'll take 3 plus log x as t. Okay. 1 upon x dx is equal to dt. This becomes my dt, right? So dt upon t log t plus c. Substitute the value of t. Done. Okay. So look here. We have this question. This is the formula for cos 2x. We'll use the a square minus b square concept. So if I solve, I am left with cos x minus sin x upon cos x plus sin x. Correct? Now, if I check my denominator part, right? So sin x, what is the differential of sin x? It is cos x. What is the differential of cos x? It is minus sin x. Means I have a derivative of the denominator. So what I am going to do? Let cos x plus sin x equals to t minus sin x plus cos x dx is equal to dt. So what it will become? It will become dt by t. So which implies log t plus c. Substitute the value of t. Log cos x plus sin x plus c. Let us take this question. See, what is the differential of x raised to the power e? It is e x raised to the power e minus 1, right? So I am getting here something e raised to the power minus 1. Differential of e raised to the power x is e raised to the power x. I am getting here e raised to the power x minus 1. So let us take it out. If we can take out from the derivative something common, and if we get in the numerator the things. E raised to the power x plus x raised to the power e is equal to t. Okay. Now let us check. So differential of e raised to the power x is e raised to the power x plus here it will become e to the power minus 1 dx equals to dt. In my numerator I don't have this part, correct? So I'll take out e common. Once I take out e common, it will become ex upon e plus x e raised to the power minus 1 dx is equal to dt, right? So bases are same, powers will be subtracted, right? So what it will become? dt upon e, right? Done. So this part can be replaced by dt by e, and this is my t, and e is constant, so I can keep it outside the integration. Plus c. Okay. What is the value of t? So this is my required integral of this. Okay. Now let us move to the next category of integration. So look here viewers, this question. We have e raised to the power sine inverse x whole square upon under root 1 minus x square. We already know that the differential of sine inverse x is 1 upon under root 1 minus x square. Correct? So what we are going to let? We will let sine inverse x is equals to t. 1 upon root 1 minus x square dx equals to dt. So this part can be replaced by dt, right? So my function reduces to e t square dt, or I can write as e to t dt, right? Now what will be the integral of this? E raised to the power 2t upon 2 plus c. Clear? Substitute the value of t. This can be written as 1 by 2 e raised to the power t whole square plus c. Now we can substitute the value of t whole square plus c. Done. So look here, we have been provided with the function 4x plus 3 under root 2x square plus 3x plus 1. So 2x square plus 3x derivative will be 4x plus 3. So what I am going to do, I will let this as t. So 2x square plus 3x plus 1 equals to t square. So what I am getting? 4x plus 3 dx equals to 2t dt. See, here is t square, so it also has to be differentiated, right? So now this part will be replaced by 2t dt under root t square, right guys? So 2t dt upon t. We can cancel this part, take out 2 outside, integration dt. Integration of dt will become t plus c. Substitute the value, this is the value of t square. So t will be root 2x square plus 3x plus 1 plus c. So this is the required answer. Let us check out this question now. X into e raised to the power x, the derivative can be this thing. So we'll check out. Product rule we'll use, right? Derivative of e raised to the power ex, dx is equal to dt. Right? See, we got it. So what I am going to write here? dt upon cos square t. Now, this can be written as secant square t dt. What is the derivative of secant square? 10t plus c. Substitute the value of t. 10x ex plus c. See, by substitution the integration becomes so easy. So students, let us check this part now. So what I am going to do, I will take out x4 outside from this bracket. Correct? 1 upon x square into, I am taking out x raised to the power 4 common, but it has power also. I am going to write like this. Okay? So now you are left with 1 plus 1 by x4 raised to the power 3 by 4 dx. Is that clear? This becomes x to the power 5. 1 plus 1 by x4 to the power 3 by 4. And we know the derivative of x to the power minus 4 is 1 by x to the power 5 kind, right? So let us check it out. So we can write this as in this manner. So minus 4x minus 5 dx is equal to dt. Okay, so minus 4 x5 dx is equal to dt, or I can write as dx upon x to the power 5 is equal to dt by minus 4. Okay, let us substitute here. Dx upon x to the power 5 will become minus 1 by 4 outside dt, and this is my t to the power 3 by 4. What you can write this as? Minus 1 by 4 integration t to the power minus 3 by 4 dt. Correct? Now we'll apply our formula. Our traditional formula, minus 3 by 4 plus 1 upon minus 3 by 4 plus 1 plus c. Correct? So what is that going to imply me? Minus 1 by 4 t to the power 1 by 4 upon 1 by 4. It is going to get cancelled, and what will be my answer? It will be equal to minus t1 by 4 plus c. Substitute the value of t. 1 plus 1 by x to the power 4, 1 by 4 plus c. Okay guys, so this is all about integration by substitution. Today we learned Introduction to Indefinite Integral, Basic Formula of Integration, Geometrical Interpretation of Indefinite Integrals, Difference between Differentiation and Integration, Substitution Method followed by examples. That's all for the topic today. Stay tuned.